This is the actual problem that a student was asking about. Let's just take it from start to finish. It's a good review of the material in chapter 6 and 7, mostly 6, I think. Anyway, notice that we have this short run production function here. Let me just go into a pointer mode. We have labor and a quantity of output. So by it's implicit that capital is fixed. Later they talk about fixed costs, so we know that for sure. But so this is a short run problem. Capital is fixed, labor is variable, and we're asked to calculate the firm's various costs from just the short run production function and a bit of information about factor costs. It turns out that's all we need. These relationships among all these concepts is reasonably straightforward. There's a lot of relationships, but they're each pretty straightforward. So let's just go through that as a matter of review. All right, so as far as the total fixed costs, remember that fixed costs are just given at 5,000, so it's 5,000, 5,000, all the way down the line, 5,000, because fixed costs don't change. Now, workers must be paid $250 a day, so if we're employing 0, there's 0, but if we've got 1, it's 250. If we hire a second worker, our total variable cost is 500, just another 250, 750. These just step in 250 increments because notice that we're always adding 1 worker. Now, if we were adding 5 workers, the total variable cost would step by 5 times 250, which would be 1250. But all right, 1,250. All right, let's. I guess I can keep going with this easily enough, just in my head. Notice that I haven't used a calculator so far. For the right side of the table, calculator is pretty handy. Total costs, all costs are either fixed or total variable costs, so we just add those two together to get total costs. And you can change these factor costs and you have a brand new problem. You can change around the production function. If you have a brand new problem, feel free to do that, and I recommend you do that as you study. Anyway, you just add the total fixed and total variable costs all the way down. Now, average fixed cost, none of these concepts is defined at 0. You can't divide a number by 0 without getting infinity or undefined. Average fixed costs is equal to total fixed costs divided by quantity. In fact, when we talk about averages across the board, we're just taking average variable cost, total variable costs divided by quantity. The one mistake that I see students make here is if they divide through by labor. Don't do that. We care about how costs change with output for this material. For some things you do. In factor market analysis, remember we asked how costs changed with an addition of 1 more worker. But this is goods market analysis, and we care about how costs move with output. Average total cost. There's 2 ways to get average total cost. On the one hand, it could be the sum of average fixed costs and average variable costs. That'll get you average total cost. But you can also take total costs and just divide through by output. And if you want to make sure that you're doing these correctly, just make sure that what you get when you calculate average total cost from one way, let's say you calculate it by taking the total cost divided by quantity, just eyeball it and make sure that's the same as the sum of average fixed costs plus average variable costs. If it's not, you made a mistake somewhere. And then finally, marginal cost. Marginal anything is always the change in one thing divided by the change in something else. And for costs, it's the change in total cost divided by the change in output, because that's what we're caring about. And because fixed costs don't change, this is also the same as the change in total variable costs divided by the change in output. And really, marginal costs we're thinking about as we move from 0 to 1 worker, or output 0 to 3,500. And here it says from 3,500 to 7,500. So when I plot these, you don't have to worry about it. But if I graph these, I always graph them at the midpoint of the 2 output levels, because that's the correct way to do it. Your graphs look a little bit funny if you do it another way, which is fine in in a test situation, but the graphing them at the midpoint is what you do. All right, so you might have just experienced a little bit of choppiness. I had to do a little bit of editing. Anyway, average fixed costs, total fixed costs divided by output, 5,000 divided by 3,500 for that first one. The average variable cost, we'd get 250 divided by output, 3,500. You're getting the idea. 5250 divided by 3,500. It's nice to have a calculator here. And the marginal cost, let's look at the change. We always have every time we add a worker, we're increasing cost by 250. Then the change in output, we go from 0 to 3,500. So actually that would be 3,500. The next one, since we go up by 4,000, the denominator would be 4,000. Here you need your calculator. I've actually pasted in the next panel the actual numbers that you get when you use your calculator. And here we see the calculator. Notice that 143 plus 7 cents equals 150. So I didn't make any mistakes so far. 67 plus 07, that's actually 74, but I get 73. That's rounding error. It's no big deal. 37 plus 9 cents, that's 46 cents. So I'm in the ballpark. This is working out. All right, let's get to the meat of the problem. What is the firm's approximate shutdown price? So here, remember that shutdown price happens if I have a little comic book of the firm's typical costs. We have the marginal cost, we have the average variable cost, and the average total cost. And so I'm looking for this point, the shutdown price. Well, that's where marginal cost is upward sloping and is intersecting with average variable cost. So I look here, marginal cost drops from 7 to 6. That's this downward sloping portion of marginal cost. Then it's up again. And notice that average variable costs are just 7, 7, 7. Those are rounding errors. So it's stuck at 7. And notice I go from 7 to 6, but then 6 to 8. Somewhere in there, and it has to be right around 7 cents, is where marginal costs and average variable costs are equal. So that's the shutdown point, shutdown quantity. Shutdown quantity would be somewhere in between these two numbers. Would be, let's see, that's a $3,000. It's about 9,000. But I don't ask you about quantity. But 0.07, 7 cents a unit. Break-even price, I'm looking for this one. And I'm going to be looking for where that marginal cost is equal to the average variable cost. And so now this is average variable cost. Let's see, marginal cost is way below average cost, still way below, getting closer. Somewhere between output 13,500 and 14,000, my marginal cost goes from being smaller to greater than average total cost. So I'm looking at 46 cents. Notice that average total cost was flat there toward the bottom of average total cost at 46. So I'm pretty confident it's 46. It probably output is closer to 1,400. Notice that at 13.5 we're at 25 cents a unit as a marginal cost, and it's almost all the way up to 50 cents by the time it crosses average total cost. If the price of a bottle is 27 cents, what's the firm's output and profit? So here, don't worry about output levels were not shown, but you would keep increasing output as long as price is higher than marginal cost. You'd stop right there because 50 cents a bottle is if it costs you 50 cents a bottle, you'd never make a bottle if all you could get is 27 cents. So we're looking for an output of 13,500, and then we're given the price. Profit, we know is equal to total revenue minus total costs, and that's going to be equal to 13,500 times 27, remember total revenue is price times quantity, minus total cost. We calculated total cost, 62.5, 6,250 I should say. And then let me do that. In my head, the firm is losing 2,605 per day. Now, would that firm continue to operate? Yes, because the fixed costs is, they shut down, they lose 5,000 a day. So losing $2,605 is better than they would do by shutting down. If you ever get a profit bigger than your fixed cost, a loss bigger than your fixed costs, you know that they just shut down. Fixed costs, changes in fixed costs don't change the output decision unless they drop profits to below the loss of the total fixed costs, which they don't. So there would be no change. And then now, the government charged the firm a 10 cents per bottle tax. How would the firm's output and profit change? And we're going to just, actually doesn't matter how fixed costs are, but, it will for profits, right? So, but now the point is, instead of getting 27 cents, they'd be getting 27 minus 10, right? Because they got to ship off that 10 cents a bottle to the government. So they'd be getting 17 cents, and their output would drop to 13. That output that cost 13 cents a unit would get produced, but the output that cost 25 cents a unit would not. So their output, if I had to choose from one of these outputs in this table, which by implication I do, falls to 12,500. So Q equals 12,500 now, and profits are equal to 12,500 times 0.17, 17 cents. Sorry, that's a little messy. Minus, now our costs are $5,000, right? We calculated them at 6,000, but then their fixed cost fell by 1,000. So minus 5,000, and that gets us to a loss of $2,875 a day. Oops, one quick correction. Output doesn't change in part E. I didn't read the part about profit. Profits rise to negative 1,605. Sorry about that. Now it's correct.